Hi guys, so my name is Cynthia and I am the director for Java 101 here at UF's First Time Programmers Club, aka FTP, and this is going to be our first session for Java 101. And basically to give a little overview of who we are here for first time programmers, so you don't need any experience to be in our club. I'm here to mentor you and kind of guide you guys through how to learn programming and coding, because a lot of people find it confusing or they're interested in it but they don't know where to start. So that's what I'm here for. So this is our first session, and I'm doing a live stream right now, but in the future we're going to have a live stream and a in-person session. So once we know more, we will let you guys know. But please sign in here. So this is going to be our Google Doc, just to get your names and everything. And then I also uploaded all of the code that I'm going to be using today onto my GitHub, and that's this URL. And we also have a lot of social media. So we have a YouTube channel called First Time Programmers, and I'll be uploading all the live streams, recordings on there. And then we have a Facebook page and an Instagram and Twitter. And then we post a lot on those also. So give us a follow and then you keep up. So let's go right into it. So basically we're learning how to program in Java, and we also follow one of UF's courses called COP 3205. There's programming one, and it's kind of everyone's first programming class really. So this is some like a basic overview. So Java is object-oriented, platform independent, meaning that it doesn't matter what platform you have, you can compile your code and run it on anything. And then once you compile your code, it gets compiled into bytecode and then sent to the JVM, the Java Virtual Machine, and that interprets your code. And it's also portable, so you can run on any machine like a Mac, Windows, Linux, whatever. And then a quick side note, Java is case sensitive, and this is very key when we start coding later, so it's good to remember. And then we're going to be coding in IntelliJ, and it is a Java IDE, which stands for Integrated Development Environment. And that basically means that it helps us complete our code, compile it, edit it, all that good stuff. And it has cool features like refactoring, which is like if you want to rename something, and then it does autocomplete also, because it understands like the context that you're in. And these words will make more sense to you once we go more into this. And then people also use other IDEs. I use Eclipse in my first 2 years here, but then the new Professor Blanchard, teaches this class in IntelliJ, so I downloaded this and I'll be using this throughout the tutorial. So first, there's a lot of words and I have pictures to show you, but I'm going to show you and walk you through how to make your first Java program. So these words can be kind of confusing, so I have pictures also for you guys. So what we're going to do is open IntelliJ or any IDE of your choice, and again I have IntelliJ. So you're going to go to File, New, Project. And once you do that, you're going to pick Java, because we're going to code in Java. And then you're going to specify the JDK in this field line. And mine's already there for me, meaning I have Java 1.8. And right here, just don't add anything here because we're doing very basic programming, so we don't need more libraries or frameworks. And then click Next. And then on the next page, you don't click anything here either. There's a next on the bottom right corner that I didn't include, and it'll take you to this next window. And here's where you're going to name your project. And I always name mine with an uppercase, but you can do lowercase or whatever, it's up to you. And you're going to do finish. So once you do that, you're going to see your file that you named. So I named mine test, and it's going to be on the sidebar to the left. So once you do that, you find your project, and then you click on the little triangle here, and then it shows you all of the files under test. And one of the folders is SRC, means source folder. And you're going to right click on that, and it takes you to this page or this little menu, and you're going to go New and Java class. And this is related to how Java is object oriented, so things are in classes, things are objects, and that's just kind of how it is. And we're going to click on that, and here's where we're making a new class. So a very basic project is Hello World, so that's what I'm going to name it, and make sure to capitalize every word in it and don't put spaces. So that's what I did. And now that you're done, you should see the Hello World file in your project. And IntelliJ fills in the first 2 lines for you. And notice how here you have the class, which is called Hello World, which is the same name as your Java class file. So there you go. So I'm gonna go to IntelliJ and I'm going to show you guys this. So basically, this is the file that I made, and this is called your main, and it's your main method, and it's kind of the starting point for all your code. And basically, right now, just kind of copy and paste these words like public, static, void, main, and then the string args into your Java file. And I can explain more in other tutorials what this means and everything, but for the sake of simplicity now, we're just gonna paste that in. And then for a print statement, we're gonna do system.out.println hello world. So make sure to capitalize S because Java again is case sensitive. And what you're gonna do here is just put in double quotes and then whatever words you want to type. So I'm gonna run this right now just to show you guys what it looks like, and I'm gonna zoom in a little so you guys can see. So run this, and then it's compiling, it's running it, and give it a second, and that should show us. Okay, here. So this is called our console, and this is where output is. So as you can see, we have hello world outputted right here. And then the process finished with exit code 0 just means that your program ran successfully. So yeah, that was our first program, and now you know how to output something to your console. So that is hello world, and the print ln means print line, meaning that you print it and then you create a new line. So for example, let's say if you want to print something else. So system.out.print, let's do a print statement. I'll just say hi, and then system.out.print, and then I'll just say bye. So I'm gonna run it and then I'll explain to you guys the println and print. And then IntelliJ might take a while sometimes, so don't worry about that. So do you see how we have in the console here, hello world, and then because it has a print line, it creates a new line, and then it goes to the next print statement, which is hi, and then the hi prints, but since the hi only has a print and not println, it does not make a new line, and that's why the bye prints directly after it. So just a little key fact to know, and then we're going to go back to our PowerPoint. So we ran it, and that's our output. And then just to go over some terminology. So every line you have in Java, like each line of code, has two parts to it. We have the statement and the terminator. And the statement is kind of like your sentence if you want to have an analogy for it. And that's like your code. And your terminator is the semicolon, and that's at the end of your statement. And it's kind of like a period at the end of your sentence. And a very common beginner mistake is to forget the semicolon. And if you forget it, your code won't work. So for example, notice how after every statement here I have a semicolon, semicolon, semicolon. Well, let's take out one of these semicolons. First of all, it'll throw an error. It'll say that the semicolon is expected because IntelliJ can sense that, and it'll give you a warning like that. And that I think if I try to run it, it won't even run, or it'll give me an error code or something like that. So let's see. See? I don't get any output, I just get an error statement, if you can see that right here. So that's why you need the semicolons. And it's a very easy fix if you catch it. Okay, so we have statements and terminators, and then now we have primitive data types, and these are basically just I guess ways to classify your data and your values. So for example, we have these data types without decimal points. We have byte, short, and int. And we mostly use int here. It's the default type for integer values, unless you're concerned about space, meaning that the byte and the short take up less space. But everyone usually uses int, and that's what we're going to use in our beginner tutorial series. And the default value for int is 0. So int is like, like negative numbers include 0 and positive numbers, but it can't be like 1.2 or it can't be pi or anything like that. But if you do want to include decimal points, you can use these long, float, and double is the default type of decimal values, and the default value is 0.0. And then we have something for true and false. It's called a Boolean, and this just tracks true and false conditions, and you'll see later in this tutorial how we do that. And the default value is false. And then characters, which is char. And that's like the letter like A, B, C, D, numbers, symbols like the ampersand, the dollar sign, the percent sign. So yeah, and we're going to go over data types in our IntelliJ. So I have that up here. So I want to zoom in, and right now we haven't gone over declaring variables yet or anything, so don't worry about that. But as you can see, I have int, and I named it something, and then I assigned 1 to it, and then double, 2.35, boolean, true, char, the letter A, and then char, the number 2. So that just kind of gives you a visual example, because I'm personally a visual learner, and I know explaining code verbally is kind of confusing sometimes. But yeah, those are data types, and we'll be using these the most so far, and then as we advance and progress, we'll be adding more. So this is our data types. And then here, so for variables, it's basically a space in memory, and then I have a visual to show you guys in the next few slides. But basically, to declare a variable, you just do the data type and variable name. So int age, semicolon. And right now it has no value besides the default value, which is 0. And to initialize it, it basically means you take out that default value and assign the variable its first value. So in this case, I assigned the value 23 to the variable age. And it's key to remember that since you already declared the variable here in age, then you wouldn't do in age again, because to the program, that's like you're trying to declare age twice. And in Java, you can't have the same name for a variable of the same type. So that's why I just put age there, because Java already knows that this variable age exists, and now it's just being told that it's being assigned a value. And then you can also combine these two things in one statement, so you can declare and initialize in the same line of code. And all you do is do data type, variable name equal sign, and then the value. And then this equal sign here, unlike I guess everyday life, is the assignment operator, and then we'll go over that later. But it doesn't mean like equality, and you'll see what I mean in like a few slides. So yeah, so this is how you declare and initialize, and just kind of going over what I just talked about. So here's a line of code that I wrote, and then you do int x semicolon x equals 1, and then another vocab word is the word assignment. And assignment is basically just giving the variable another value. So here we already declared x, and then we initialize x with the value 1. Well, let's say later on in the code we want to change this, and then I made x equal to 4. And then what happens in memory is when you declare a variable is this. So when I did int x in memory, that declared a space allocated for a value of type int, of the data type int, and named x, and then right now it's empty. And then when I initialized it, I gave x the value of 1. So that's how the memory works, and it's pretty cool. So one more thing, so literals is the constant value that is assigned to a variable. So back in this example, the literal is 1, the literal is 4 here. And when you declare data type, you declare variable because data type determines the size and layout of the variable memory, the range of values they can store in that memory, and a set of operations applied. And just a few naming conventions. Variable names can't start with the $sign or the underscore, and the first letter of the name should be lowercase. And the variable names with multiple words start with uppercase letters. So they call this camel case, where the first letter is lowercase and the other ones are uppercase. So I think that's it for variables. All right, we're going to do some examples. So here, let's make this code a bit bigger. Okay, perfect. So hopefully you can all see, but in this section we're declaring a variable here, and then we're going to initialize it to 3, and then we're also declaring and initializing a variable in the same line right here. And then I'm just going to print stuff out for you just to show you guys. So we have the print statements here, and then I'm going to run it. Okay, so just ignore these other inputs for now, but as you can see, x, for these two inputs, x and 3, x is 3 as we put here, and that's printed out, and then y is 23, just printed out here. So it also shows another way to use the print statement. You can just put the variable name inside, and then it'll print whatever value is out. So that's pretty cool. And we can also combine the two by doing like math, and we'll go over this assignment later. But basically, this is adding the two values. So x is 3 and y is 23. So then here, in our third line, you see 26 because this is our third print statement. So yeah, so that's kind of going to show you guys declaring and initializing variables. And we went over this. And then identifiers are basically names for your variables, classes, objects, whatever it may be. And again, it is case sensitive. And there's certain rules, like you can't start with a digit or reserved keyword, which are on the next slide, or use spaces. So these are examples of what you can't do. And then you can use capital and lowercase letters, digits, underscores, the $sign right here. So this is just for the general case, but then for variables, it can be different. So yeah. So then here are the reserved keywords. You can find this online on the Java website, and you can't use these in your program. So for example, if I pick the word Boolean, right? If I try to do, if I want to name something like int Boolean, it gives me an error. So that's just something to remember, and you can name a variable whatever you want, but usually for me it makes more sense to name it things that describe it. Like right now I'm using x and y because I want to demonstrate it, but later you're going to see that people will change the variable name to describe what value it's holding. So also you can't use the words true, false, and null. Even though they're not keywords, they're still literals. So you can't use them as identifiers either. Moving on to comments, as you might have seen in my code, I have these like greenish lines or these dashes, and basically comments are not looked at by a compiler or interpreter. So whatever you put there, the compiler won't see and won't read over, but the comments are there for us, the people. So it helps explain what your code does to other people who's looking at it, maybe a teacher, a TA, even yourself sometimes. Like there are times where I code something and then months later I look at it and I'm like, damn, what did I do here? But having comments there makes it more readable and understandable. And it also breaks up your code into logical blocks, which I'll show you in my IntelliJ code also. And you can also explain the variables you make, the methods, classes, or any statement if you feel like it might be a bit unclear. And when you're also debugging stuff, you can hide parts of the code that you might think be giving you trouble, and then that can help you debug your program, which I'll show you in later sessions also. So you have two types of comments. You have a single line comment, which is here. It's the 2 forward slashes, and you just type a bunch of stuff, and that just spans the entire line. But as soon as you go into a new line, it's not a comment anymore. So if you want to add something short and sweet, I would do a single line comment. And if you want to do like large chunks of text, I would do a multi-line comment, which is a / asterisk, and then an asterisk / So here I'll show you. So as you can see, here's my multi-line comment, and then I'm just telling myself and whoever reads my code the purpose of the code below. So here I want to show you guys how I declared variables, initialized them, which is why I have this comment here. And then I have my one-line comments here to explain what the variable does and what I'm doing here. So it's pretty cool. And then in later parts, you see how I use this to divide my code up into just like logical chunks. So it's more organized, more readable, whoever looks at it. So yeah, those are comments. They're very useful. Definitely comment your code whenever you can because it helps people understand it. And then white space. So basically white space is where code doesn't exist. So it can be a space bar, tabs, hitting the return key. So for example, like this. Like right here, this is all white space. Here, like after, like if I do a space, that's all white space. If I do enter, that's all white space. And to the compiler, this is the same thing as this because the only thing that changed is the white space. And again, it's kind of like a comment where it's more for us because if I had, let's say, all my code like this, all like mushed together, then it's just kind of like hard to read. And as your code gets bigger and bigger and more complex, it just becomes harder to read and follow. So whitespace and comments are there for you guys and not the compiler because you can write your entire program on one line of code and it'll still compile it and understand it, but it doesn't make the code as user-friendly. And let me see, and here, my Hello World file, so all of this right here is also white space, but I put it indented because it shows kind of where the code belongs, because I know that these 3 lines of code belong in the main, which are in the Hello World class. But if I had all this code, for example, out here, then like it's just harder to follow. So it's a good practice to use whitespace and comments whenever you can. So yeah. Okay, so now we went over how to output things onto our console. So again, going over this, we printed out, let's run this again. So we printed out hello world to the console. So it's kind of like things that I want to say or I want to output. And then you can see it on the console in 1 second. So here, still hello world, hi, bye. That's what I'm trying to say. But what if you want to take an input from like a user or the keyboard, right? What if you want to ask, let's say, a question like, how old are you? Or making the user pick an option. That's when you have to take in user input. So to do that, we have a scanner class. So this lets you take an input from the keyboard. So we're going to go over just a little slideshow of this, and then I'll show it to you live also. So you need to have an existing program. If you don't, make a program with the directions I gave you guys before in the first couple of slides. And then once you have a program, you're going to add this line of code first, import java.util.scanner semicolon. And this basically imports pre-written code for you to use. And after that, oh, also, you want at the very top of your program. So do you see how I have public class like lab3 here? And then above it, I have the import line. So you want that above it. If you put it inside, it will give you an error. And your next step is you want to add this line, scanner input equals new scanner system.in into your main. And that basically creates a scanner. And I named it input right here, but you can name it whatever you want. But to me, input just makes the most sense. And I'm going to go to the next slide. And here, you're going to make a variable because you want to take in the input, right? But you have to put it somewhere. So that's where our variables come in place because our variables hold information for us. So you're going to declare a variable. I use int age here, but you can do any of the data types and whatever name you want. It could be a double, it could be like a boolean, a char, whatever you want. But for the sake of simplicity, I'm doing int age, and then you're doing do an equal sign, and then input.nextInt. And basically this takes the input, so do you see how the input here and input here are the same thing? It just takes the input from the keyboard and then it tells the computer, okay, it's going to scan the next token for an input as an int. So that's what the next int means. And it'll all make more sense when I show you guys. But basically the input scanner scans the token, takes in the input, and then it puts the input in age, the variable age. And we're going to, and then, so this program, I'm gonna show you guys actually. So let's go to my program here. So as you can see, let me zoom in for you guys. So as you can see, we did import our java.util.scanner, and I named my class take input when I made a new class. I have my main, and then I made my scanner, so scanner input equals scanner, new scanner system.in, and here I'm outputting right now, and I'm outputting, hello, how old are you? Because I'm asking a question to the user. And then here is when I'm going to wait for them to input a value. So I'm going to run it for you guys so I can show you. So I'm going to run take input.main. Okay, so see, in the console down here it says hello, how are you? Which is to be expected. And then you see how even though we have a second print statement down here, the console's not going to print it. That's because it's waiting for the keyboard, like the user, to input an integer. So I am 20 years old, so I'm putting the 20 in here, and I'm going to press enter, and then that's when the code finishes. So I put in 20, and then the input scanner scans it, and it takes it in as an int, which it is. I put 20, not 20.1 or anything like that. And then it puts that value, the value of 20, into the age variable. And then that is saved. And then once we output it, it outputs as 20 years old. So in this output statement right here, I put you are, and I put a space, and then I put the age and 20 years old. So if you ever want to use the double quotes for any words you want to output and a variable name, you have to use this plus sign, and that concatenates everything. And the word concatenate just means to like put together, to add together. So in here, we just had this. When we had the variable name in here, nothing else. But now we're combining this idea with the double quotes idea. And if you want to format it a certain way, so here I added a space, and then here I added a space, and that puts a space between the age here. So if I were to take it out, for example, so copy, paste, or just delete these two spaces, then I'll show you. Okay, so how old are you? 20 years old. And then do you see how comparing these two lines, the first line has a space between 20, and then this one doesn't, because the program outputs exactly what you tell it to. So the space is here. There's no space here, but these spaces don't count since they're not inside the double quotes. So hopefully that makes sense to you guys. But yeah, just a little key thing to remember. So yeah, that's how you do user input, and it's pretty cool because you can ask the user for things, and then you can be more interactive with your program, and we'll see that later also. So that is our scanner class, and I just went over the stuff here. And okay, so now we have operators. So I think you've seen them a little bit in my code, but we have 3 different kinds. We have the arithmetic operators, and then we have the plus sign, which is addition, the minus sign, subtraction, the asterisk, multiplication, the / division, the percent sign, modulus. And this is pretty cool because this gives you the remainder. So if you remember, if we ever divide stuff, if two numbers don't go into each other evenly, like if I divide 5 by 4, that's not going to give me an even number. Like if I divide, let's say 6 by 2, I'm going to get 3. No remainder, just 3. So the modulus just gives you the remainder of something, which I'll show you in my code. And then plus plus means increment. So to increase the value of the variable or whatever by 1, and then the minus minus means decrement, which means to decrease the value by 1. So in our example here, if b is equal to 20, if I do b plus plus, I get 21. Just it takes a 20, and then it adds a value of 1 to it, and it's 21. But if I do b minus minus, then it takes 20, and then subtracts 1, and now I have 19. And then the rest here should make sense to you, adding, subtracting, multiplying, dividing. And then for the modulus, we have 20, which is b, divided by a, which is 10. So 20 divided by 10 is going to be 2, no remainder, which is why it'll give you 0, because it wants the remainder. And a lot of people get confused with like modulus with division, so just remember that division gives you, I guess, what you're used to, like the actual number, and then modulus gives you the remainder. And then there's like these words called pre-increment and the post-increment. So it's all about the placement of the plus plus or minus minus. And for the pre-increment, if you put it in front of the variable name, the increment operator is applied first, so it'll increment it first, and then it'll do the rest of the expression. And I'll show you guys that in code. And then post-increment is you do the expression first, and then you apply the operator, the plus plus. So for example, in my operator, okay, so I have this section of code here, and this is the arithmetic operators. So you have the plus, the minus, the multiply, the divide, and the modulus. And I'm going to run this for you guys first. Okay, so we're just going to look at here, this bit of code. So far we did this, right? This is just basic adding, subtracting, and everything. And then for the print statement, it's going to output exactly this because it put in double quotes. And then you can do like the actual math inside the print statement if you want. So here you can do number 1 plus number 2, and then these two are variable names, and then it'll take in the value, so 120, and it's 120, which you see here. And then if you also wanted, you can make a third variable. So we're going to declare int, I'm going to do sum equals, I think I already used the word sum. I'll just do num3 equals, and then I'm going to do num1 plus num2, and then semicolon, and here we can replace this, so I want to just copy it just to show you guys. Num3. So basically, these two lines of code, this one with the num3 and this one with the num1 plus num2, are going to give you the same output because num3 is basically equal to number 1 plus number 2. So these two are equal. So if you go back to our console, as you can see, the first two lines of code, which correspond to our first two print statements, are exactly the same. So it's just kind of like a preference if you want to make a different variable or if you want to just do the math directly in here. It's up to you. And then here's an example of the modulus where you get a remainder. So x is 5, y is 4, and then I'm doing x modulus y, so 5 divided by 4, and that's going to give you a remainder of 1, as you can see here, right here. So that shows you the arithmetic operators, and we're going to go on to increment. So here's increment. So x here is 5, so I declared it, initialized it up to here to 5. And now we're taking x, and we're doing plus plus. So after this, x is going to be 6. And then we're taking y, which is 4, and then we're doing minus minus. So we're going to decrement y by 1. So our expected output should be 5 plus 1 should be 6, and then y minus 1 should be 3. So as we see here in our console, we have 6 and 3 being outputted, which are our next two print statements. And then this is going to show you the pre-increment and post-increment. So let me zoom out a little bit. Okay, so here, I'm going to do this. So I'm going to go to this example because to me this makes more sense, and I think it's easier to explain. So we have a new variable of type int, and I named it k, and its value is 10. So we're going to have a print statement, and the print statement is kind of like our expression. So as you can see, we have k++. And since this is post increment, like I said in PowerPoint, you're going to evaluate the expression first, so you're going to do the print statement first, and then you're going to increment it. So here in my comments I wrote, it's going to print 10 first because k is currently 10, and then after it prints, it'll increment k to 11. So as you can see here, in this output we have 10, and this corresponds to this line. So then next, we're going to do the pre-increment to k. So right now, k is 11 because we incremented it after the print. And if you want to, we can check by doing system.out.print, just print out k, and this will tell us what k currently is. And hopefully you guys can see that. So I'm gonna let it run. And, okay, so we are here. Oh, I didn't do printing. Sorry. And I just changed it from print to print line because it's gonna look easier to. It's gonna be easier to explain in the console. So right here. So we'll zoom in again. So our first print statement with k++ outputted 10. And then now k by itself is 11, which means we were right. And then now in our third print statement, we have ++ k. So with pre-increment, it's going to increment k first. So it's going to be 11 to 12, and then it'll print out k. So increment first, and then it'll do the expression, which is a print statement. So as you can see, the next value is 12, right here. And then we have decrement also, and decrement works the same way as increment, just the opposite. So k is currently 12, and now we're going to print out the current value of k, which is 12, and now we're going to decrement it to 11. So as you can see, we see 12 here again, and then after this print statement, k is 11, and we're gonna, I'll make a comment here. K is 11 before we execute this print statement. Okay, and then here we have the pre-decrement. So meaning we're gonna decrement k first, so it's gonna go from 11 to 10, and then we're gonna print out the value of k, which is 10, and you can see that right here. So hopefully that explains to you how the placement of increment decrement affects your code. So we have this. So arithmetic operators we went over, and then now this happens a lot, and people kind of get confused about it. So it's called integer division. So the int data types don't have decimals, and that means if you divide two integers and there's a remainder, like a decimal, like if I divide like 5 divided by 4, I get like 1 point something, then you're not going to see the decimal after it. You're just going to get a 1. So the solution is just change your data types from ints to doubles, because the doubles do have decimals, and once you do your division, your answer will have a decimal also. So I'm going to show you guys that. So I think that's here. Alright, perfect. So integer division. So here we have this. I have int a equals 4, int b equals 3. So these are both integers, no decimals. However, if we divide them, a divided by b, we know that 4 divided by 3 isn't going to give you a clean integer. It's just going to give you like 1.333. So I'm going to run this and show you guys. So I'm going to comment this out. So what I was saying about commenting things out is sometimes if you don't want a certain part of your code to run, you can just comment it out. So I want to just do the /**, and then the asterisk / here. So now all this code, all these print statements won't run, and it'll make our console have less output. So let's run this, and then let's see. Okay, so I'm going to comment this out also. What I just did there is I just highlighted all this code, and I just pressed Control / on my Mac, and it just comments it out for you. But it's a little shortcut you can use if you don't want to do it manually. So here we have our console again, and as you can see, we have 1. So we have 4 divided by 3, and the answer is actually 1.33333, but since these two are integers, it's only going to give you 1. And then even though our result is of the double type, which has decimals, it's not going to include the 0.333, because our answer is 1.0, and that is a decimal, so it is a double. But since we have 2 integers here that are being divided, it's not going to include the decimal, like the remainder after it. But if you change it, so let's uncomment that. So remember the solution was to just change these integer data types to double. So we're going to do that here. And notice how, for example, you can't do this. So since I already initialized and used the letter A as a variable name, I can't do that again, even though I changed the data type. And IntelliJ will even tell you the variable A is already defined in the scope, meaning that in this block of code, A is already defined to be something. So that's why I just renamed it N and M. So then, yeah. So then basically now we're going to run it, and then I'm going to run them side by side so you can see the differences. Okay, so here. So our first number, 1.0, is from our first line of output, which is the integer division. But then once we did our solution, we fixed it by making them doubles. We then have our answer, and that includes the decimals. So that's pretty cool. So we have that. That's just like a key thing to remember, because sometimes it can cause errors in your code and everything. And then we have also relational operators. So we have the equal sign, which is the 2 equal sign together, not equal to, greater than, less than, greater than or equal to, less than or equal to. And these are pretty self-explanatory conceptually, and I can show you an example also. So we have the relational ones. So I'm gonna just copy this piece of code, and I'm gonna put it somewhere else because I have a lot of stuff in this file, and I feel the console's getting a little bit cluttered. So we're gonna put it in here, and then I'll comment this out. Okay, so now it'll be cleaner. So I'm gonna run this. And it's okay to move code around. It doesn't matter if it started off in one class and moves to a different class. That's totally fine. So, alright, here we are. So we're gonna zoom in here. And we have all of our output. So we made, I renamed this to R and T, but they were A and B before, so variable name was A, variable name was T. So, yeah, so one is, so R is 10, T is 20, and they're checking for equality, if they're not equal, if they're greater than, less than, greater than, equal to, less than, or equal to. And then these are called relational operators, and these will give you a true or false value, as you can see in the console. So is R and equal to T, is 10 equal to 20? No, so it's false. And then this is not equal to, so is 10 not equal to 20? That's a true statement, so that's true. And then is 20 greater than 20? That's false. But is 10 less than 20? That's true. And is 20 greater than or equal to 10? That's true. Is 20 less than or equal to 10? That's false. So it's pretty simple. Just remember these symbols and then you're going to be okay. Remember, these give you a true or false. So you're going to see later when we do conditionals, that's what we're going to use a lot. So we have that. And then these are logic operators. So for logical AND, it's going to be the double ampersand. For the logical OR, it's going to be this double like straight line. And that is on my Mac, it's above my backward slash key. And then the exclamation point is not. So that negates stuff. So, for example, let me get the code out of operators. Do I have the logical ones? Yes, I do. Alright, so I'm going to do the same thing I did before by just copying this into my hello world, and this I don't need anymore. And we're just going to run this and show you guys the logical operators. Okay, so I made B1 true and B2 false. So if I do B1 and B2, that's false. If I do B1 or B2, that's true. And then we're going to do the not. So we know that B1 and B2 is false because these two aren't the same. But then if we negate a false, it's going to be true. And then I have these logic tables for you guys to look at, because this explains how you know what's true and what's not true. So for the logical AND, the expression here, P and Q, is only true if both elements P and Q are true. So as you can see, P is true, Q is true, the whole thing is true. But if one of them's false, or if both of them are false, then the whole thing is false. And then for OR, it's kind of like the opposite case. For OR, you only need one of these elements, the P or the Q, to be true for the whole expression to be true. So as you can see, P is true, Q is true, it's true, P is true, Q is false, but we have one true, which is P, so the whole thing is true. And then here, P is false, Q is true, but we have one true, so then P and Q are true. And then for the last case, P and Q are both false, so since there's not one true in there, the whole thing is false. And then for not, it just is like the opposite. So if P is true, then not P is false. If P is false, then not P is true. So that's pretty useful also when we do conditionals and just anything with like if-else statements that we'll see also. And then these are the assignment operators. So this seeing your equal sign is for assignment. That's what we've been using here. I'm assigning the value of true to the Boolean variable b1. I'm assigning the value of false to the Boolean variable b2. That's assignment. I'm giving it a value. It's not equality, which is the double equal sign. So if I were gonna write something, like if I wanted to know, so equality meaning like if I want to compare two values, like if b1 is equal to b2. So if you were going to ask that question, if they're equal, then you would use the double equal sign. And then I'll show you that in a if statement because that makes more sense there. And then these are the other ones. So if you have the and an equal sign, that's basically shorthand for this. So if C plus equals A, that's going to be C equals itself, C plus A. So it's kind of like a shorthand for it. And these are basically our arithmetic operators plus the assignment variable. So you're doing some like arithmetic on this side, and then you're assigning that value to this variable. So I have that also in my code. Where did it go? Assignment, oh here. So we have the assignment operators. Okay, copy, and then I put that in here also. And then we're gonna run this. Okay. Okay, so we have A is 10, B is 20, and C right now is 0. So right here, we did just the plain equal sign, C, C equals A plus B. So you just add A plus B normally, which is 30, and then you assign that value of 30 to C. So C is 30, as you can see here. Let me zoom in. Okay. And then now we have the plus equal sign. So that basically is, so we're basically saying C is C plus A. And C right now is currently 30. And A is 10. So it's going to be 30 plus 10. And we get 40. So 40 right here. And now we have the minus equal sign, which is C equals C minus A. And I'll write this. C is 30. C is 40. Okay, so now C is currently 40, and A is still 10. So that's going to be 30. So C is back to 30. And then now we have the asterisk equal sign, and that's going to be C equal C times A. So C is 30, and A is 10. So 30 times 10 is 300. So I should capitalize these because a capital C and a lowercase c are two different variables. So just to practice what I preach. So we have 300 here. And then now we're going to do the division. So we're going to, so C slash equal sign A is C equals C divided by A. And this is going back to our integer division where C and A are both ints. So when you divide these two, when you divide 15 by 10, it's going to give you like 1 point something. But since they're both integers, we're only going to get the 1, and the decimal point gets cut off. So C here is 1, and then you scroll down, it shows 1 here. And now we have the modulus, and this is going to give us the remainder. So C equals C modulus A. So 15 divided by 10 is going to be, I think, 1.5. I'll get a calculator out and check, because I'll be sure. 15 divided by 10. Ooh, 1.5. Okay, so the answer is 1.5. And we have the 1 here because, again, it's integer division. And then now we have the remainder, which is going to be 0.5. So then we're going to output just the 5, not the decimal point. So that's what we have here. So those are assignment operators, and it's very, very important to remember that the singular equal sign is for assignment, and it's not the same as the equality equal sign, which is double assignment. So that is a very common mistake people make, so don't be the one to make it. And there's also a precedence of operators, and this is a table that I found. So it's kind of like, think of like PEMDAS in math, where you do parentheses first, exponents, then multiplication, division, addition, subtraction. So it's like the same idea with our operators. So for example, like the multiplication, division, and modulus goes before the adding and subtracting. And then just refer to this if you need to, but ignore the bitwise stuff we went over yet and the ternary stuff, because right now it's not relevant, but it's just good to know. And then we're going to go over conditionals. So that's if statements, if else statements, else if statements. And basically this is where the program makes a decision or makes a choice based on a condition. So we're going to run our code and fall into this diagram. So it's kind of like our line of code, our program. And then it's going to hit a condition. And then based on this condition, if the condition is true, then there's going to be some code that the program's going to run. And then it's going to follow along back to our regular program. But if the condition is false, then it's going to skip this code entirely and just go back to our program. So it'll make more sense. I'll show you an example. So we have our if statement, like our most basic one. So the basic format is if, and then in parentheses, a condition, and then we have a curly brackets, which kind of, it just tells you it's a certain like block of code, and then all these statements are going to go inside that block of code. So the code inside the if statement, like this blue, is only going to execute and only going to run if this condition is true. So this just follows our little flowchart again. If the condition is true, you run the if code. If it's false, you skip it entirely and go to whatever code comes after the if statement. So we're gonna go here. Oh no, I forgot it. 1 second, let me get a plug in. Okay. That should have. Oh, see, I'm charging. Okay, so we have our if statement, and we're gonna copy that and put it in here. Alrighty, so we have a variable num of the data type int, and its value is 70. So basically, we're going to run our code, and the code is going to hit this if num is less than 100. And again, here's where we're going to see our relational operator. So if we go back, so relational, here we go. So we have the less than sign. And remember that this will evaluate to a true or false. And that applies now to our if statement, because if it's true, then the code runs. If it's false, the code doesn't run. So that's where it comes in handy. So we're going to go into our if statement and go into the condition. And we're going to ask ourselves, is num less than 100? And since num is 70, and 70 is in fact less than 100, then we're going to go into our print statement, into our if statement, and look at the code inside. So in these brackets, we're going to look at the code inside. And the code inside is a singular print statement. And it just says the number is less than 100. So we can run that just to show you guys. See? The number is less than 100. But let's say, I'm going to show you an example where okay, so let's just say I change this value to 700, right? So we're going to go in here. 700 is not less than 100. So this num less than 100 is going to evaluate to false. And since this is false, the if statement and anything inside isn't run. And it'll go to the next line of code after the if statement. So these brackets tell you when the if statement starts and when it ends. So this is the first line of code after the if statement. So let's run this. Okay, and then now in our console, as you can see, we don't have the statement number is less than 100 anymore, like before, because this condition was false. So it just skipped all of this code in the brackets entirely, and then went to this print statement. We did not go into the if statement. So that's how if statements work, and it's pretty cool. And I think for today, that is what we're going to go over for now, because we are running out of time. But next time we're going to go over if-else statements, nested if statements, and then if-else if statements, and also a switch statement. So just to go over today, we went over, let's go all the way to the beginning. We went over what Java is, and then what IntelliJ is, and that's what I was using all video to code in, and that's what ran my code for me, compiled it for me, told me errors or warnings, and then we made our very first Java program using all these steps, making a new project, and then making a new class, and then we added our main method, and then a print statement. and hello world, which is a print statement. And that was outputted. And you know, over a statement, which is all your code, like each line of code, and then the terminator, which is the semicolon that ends your statement, and it's like a period for you in coding terms. And then our data types, and we use the int, double, boolean, and char the most often. And the other ones we will use, but right now we're using those 4. And ints for integers, so negative numbers, so the number is 0, positive numbers, but no decimals. And the double takes care of decimals for you. And the boolean is true or false, and char is a character. And then to declare a variable, you do data type, variable name, initialize it, you give it a value, and then you can combine these two into one statement in one line. And this is about the memory, so when you declare a variable, it puts aside a space in memory for you, and then once you initialize it, it'll put a value in there for you. And unique conventions, identifiers, which you can and can't use, reserved keywords that you can't use in your identifiers, comments, which have been like all these things that I've been using that just take out parts of code so your compiler won't look at it and it won't read it. And white space is just for readability, and again, your code will be the same like without white space, which is kind of like good practice to use it, and because the compiler ignores it anyways, but it's just to make it more readable and to make it seem like more logical. And then we have the scanner class, which takes in user input, which is here. So this is our whole program, and then it takes in user input. This is the console. It asks how old are you. I put in something, and then it runs the rest of the code, and then it outputs the age that I put in. And then we have all of our operators, arithmetic to do math, and then our division, which is with integers, it'll cut off the decimal remainder if there is one. So to change that, just make things double, and that'll include the decimal remainder. Relational operators, which evaluate to a true or a false, and that was used in our if statement. And then the logical ones, which correspond to these tables, and these can also be used in our if statement, which I'll go over in the next tutorial. And then our assignment operators, which just do some math and then also assign that result to a variable. And then remember how our assignment, our singular equal sign, and our equality operator are different, because one is one equal sign, the other one is two equal sign. And then we have the precedence, which is kind of like the PEMDAS in math, what's evaluated first, what has more importance. And then our first conditional, which is our if statement, which runs, so the code is going to run all these things, and then it's going to go to our if statement. It's going to look at the condition. If it's true, it'll output or run whatever code is inside these two brackets. If it's false, it'll skip over the entire if statement and whatever's inside and just output whatever line of code comes next after it. So yeah, so next time we're going to go over more conditionals, and that'll be super fun. And hopefully next time we have a room, and we will let you guys know in our Facebook group or our Twitter and Instagram, because we're going to have a live stream and a room next time, so you guys can tune in either from your apartment, a dorm, or whatever, or come in person. And again, follow us on our social media, which if you haven't seen is First Time Programmers for YouTube, and then UF First Time Programmers FTP for Facebook, UF FTP for Instagram, and Programmers Time for Twitter. And please fill out this Google Doc, or no, this Google form, sorry, and that will just kind of give me an idea of who's attending and attendance and stuff like that. And then all the Java code that I used today, I put on my GitHub, and that is for you guys to look at, to play around with, because having the code yourself to look at and mess with is kind of fun sometimes, and you can learn that way. But yeah, so thank you for watching, thank you for coming. I'll see you guys next week. Bye!